Good morning, students. This is Sonia Khetrpal, KV number 3 AGRA TGT Science. Today, we will discuss chapter number 1 from Science class 10th, that is Chemical Reactions and Equations. In this chapter, we will study about different types of chemical reactions and how to write their chemical equations. First of all, there are two types of changes. The first one is physical change and the other one is chemical change. A physical change is a one in which the state or the color or the size of a substance changes. Means the physical properties are changed. It is called as a physical change. Whereas a reaction in which a new substance is formed is called as a chemical change. A chemical change involves a chemical reaction. Suppose you have magnesium ribbon and you are burning magnesium ribbon in oxygen. A new substance, magnesium oxide, is formed. So it will be a chemical change. Whereas you have a piece of paper. You tear the piece of paper into 4 parts, then it will be just a physical change. You are just changing the size and shape of a paper. A chemical reaction is a process when the reactant gets converted into a product. It can be under the influence of a catalyst. We represent a chemical reaction either by a word equation or by a formula equation. Chemical equation is just a symbolic representation of a chemical reaction. Now, how do we identify a chemical reaction, whether it's happening or not? A chemical reaction is identified basically by 3 factors. Either change in state, or change in color, or evolution of a gas, or change in temperature, or any of these. According to law of conservation of mass, matter can neither be created nor be destroyed in a chemical reaction. Therefore, there is a need to balance a chemical equation. The number of atoms of an element on right hand side of a chemical equation should always be equal to number of atoms on left hand side of a chemical equation. As I said, when magnesium is burned in oxygen, it forms magnesium oxide. When we are representing it by a chemical equation, we should know the formula of magnesium, oxygen as well as magnesium oxide. When we write this, that Mg plus O2 is giving us MgO. So it should be balanced. Like here, oxygen is O2, whereas in MgO, it's single O. It needs to be balanced. For this, to balance the chemical equation, first draw boxes around each formula. Do not change anything inside the boxes with balancing the equation. List the number of atoms of different elements present in the unbalanced equation. Start balancing them with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Now, we will come to types of chemical reactions. There are basically 5 types of chemical reactions. Either it's a combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. First of all, we will study about combination reaction. A combination reaction is a reaction in which 2 or more substances combine to form a single substance. I repeat myself, when 2 or more reactants combine to form a single product, it's called as a combination reaction. As the word says, combination means combining. For example, calcium oxide, it's quicklime. When it is dissolved in water, it forms calcium hydroxide. Calcium oxide reacts vigorously with water. The container in which we are mixing both of them become hot because in this process heat is given out. Such type of reaction in which heat is given out are also called as exothermic reactions. Exo means out and therm means heat. It means a reaction in which heat is given out is called as an exothermic reaction. So when calcium oxide is treated with water, it forms calcium hydroxide. When we are burning natural gas in our homes, it is also a kind of combination reaction because the methane gas present in our LPG burns in oxygen to form water and carbon dioxide. That is also a combination reaction. Making of compost is also an exothermic reaction because in this also heat is given out. Whenever you touch a pit in which you are making compost, you will feel hot. It is because it is an exothermic reaction. So exothermic reactions are those in which heat is given out, and mostly the combination reactions are exothermic reactions. And opposite to exothermic is endothermic reactions. Endo means in, therm means heat. A reaction in which heat is given to the reactants is called as endothermic reactions. Like during digestion, when we digest our food, the complex food is broken down into simpler substances and absorbed by our cells to release energy. This is an endothermic reaction. Decomposition reaction. Decomposition reaction is opposite to combination reaction. Substance is broken down into two or more products to form, for example, iron sulfate. Iron sulfate is green in color. They are crystals of green color. When we start heating them, first the water of crystallization comes out and the color fades away of iron sulfate and becomes white in color. And we continue to heat iron sulfate, it changes into iron oxide and a smell of burning sulfur comes out. It is because of the evolution of sulfur dioxide and sulfur trioxide. Why it is called a decomposition reaction? Because we have taken a single compound and it breaks down into three compounds, that is iron oxide, sulfur dioxide and sulfur trioxide. Another type of decomposition reaction in which we are giving electricity to decompose a substance is decomposition of water. For the decomposition of water, we take water in a container and add a little of sulfuric acid to it and we start conducting electric current through it. Slowly, the water contained in the container start decomposing into hydrogen and oxygen. Hydrogen evolves at cathode and oxygen evolves at anode. In this way, water is decomposed into hydrogen and oxygen with the help of current. It means we are supplying the energy in the form of electricity to decompose water into hydrogen and oxygen. There is one more kind of decomposition reaction, that is photolytic decomposition. In this, energy is supplied in the form of light. For example, we take some silver chloride in a china dish and place it near the window, from where diffuse sunlight is reaching that china dish. Slowly, the white color silver chloride start decomposing into grey color silver. It means that it has decomposed. Silver chloride has broken down into silver and chlorine. This reaction is used in white and black and white photography. All these reactions shows that energy is absorbed during decomposition reaction. It means most of the decomposition reactions are endothermic reactions. Now come to next type of reaction, that is displacement reaction. Displace means to remove from the place. A more reactive metal or a non-metal displaces a less reactive metal or non-metal from its position, then it's called as a displacement reaction. For example, zinc plus H2S. Zinc is displacing hydrogen from its place because it is more reactive than hydrogen. So it will displace zinc. Zinc will displace hydrogen from H2S and form zinc sulfide. Similarly, if we take copper sulfate in a test tube and we add iron nails to it, after some time you will see the blue color of copper sulfate will change to green. It is because iron has displaced copper from copper sulfate and it is formed iron sulfate, which is green in color. This is called as a displacement reaction. A more reactive metal or a non-metal has displaced a less reactive metal or non-metal from its salt solution. Some common examples of displacement reaction: zinc plus copper sulfate is giving zinc sulfate plus copper. Copper sulfate is blue in color, whereas zinc sulfate is colorless. Similarly, aluminium plus copper sulfate is giving copper plus aluminium sulfate. It is because aluminium is more reactive than copper, so it is able to displace it from its salt solution. Then iron plus copper sulfate is giving copper plus iron sulfate. Iron is more reactive than copper. It has displaced copper from copper sulfate and formed iron sulfate, which is green in color. Similarly, lead plus copper chloride is forming lead chloride plus copper. These reactions are possible because these elements, zinc, aluminium, iron, are more reactive than copper. So they are able to displace it from its salt solution. Now we will come to double displacement reaction. It's a kind of reaction in which exchange of ions takes place between compounds. It's simply exchange of ions. For example, silver nitrate plus sodium chloride. As you have seen, sodium is combined with chlorine and silver with nitrate. They will exchange their ions. Silver will combine with chlorine and sodium will combine with nitrate. And they will form silver chloride plus sodium nitrate. In such type of reactions, an insoluble substance is formed, which is called as precipitate. So, these kind of reactions are also called as precipitation reaction. Precipitation, because precipitate is formed. Precipitate is nothing but an insoluble substance formed when we are reacting two compounds together. Common examples of precipitation reaction: we have taken silver nitrate plus potassium carbonate, and they are reacting and a new product is formed which has a PPT. Now we will come to redox reaction. Redox, the words is made up of two words, red plus ox. Red means reduction and ox means oxidation. Oxidation is a process in which either oxygen is added or hydrogen is removed. For example, we are burning hydrogen in oxygen. H2 plus O2 gives water. It's an oxidation reaction. We are oxidizing hydrogen to water. Then comes reduction. It's just opposite of oxidation. In this, oxygen is removed and hydrogen is added. And a reaction in which both oxidation and reduction takes place simultaneously are called as redox reaction. Most of the reactions are redox reaction. If something is getting reduced, the other reactant must be getting oxidized. If somebody is losing oxygen, the other one will be gaining oxygen during that process. So most of the reactions are redox reactions. Some example, methane is burnt in oxygen. In this, methane is turning into carbon dioxide and water. So methane is converted into CO2. That's an oxidation because oxygen is added to methane and oxygen is converted to water. In this, H2 is added to O. So it has become water. It is reduction reaction. Other examples, magnesium is burnt in nitrogen to form Mg3N2. C plus O2 giving CO2. Carbon is oxidized to carbon dioxide. Corrosion and rancidity. Metals are reactive in nature. So they react with air, moisture, acid present in our environment and lose their luster or shiny appearance. It is called as corrosion. This also results in weakening of the metal. When a metal is attacked by a substance around it such as moisture, acid, etc., it is said to be corrode, and this process is called corrosion. The black coating of silver and the green coating on copper are other examples of corrosion. For example, iron. When iron is left in air for some time, we see a brown color flaky layer on the iron articles. It is because of rusting, and rusting is a kind of corrosion. That brown flaky layer is called as rust. It is because iron has reacted with oxygen and moisture present in air and it has formed rust. Similarly, when silver articles are kept in air, they become black in color. It is also because of corrosion. Silver has combined with sulfur to form silver sulfide, and silver sulfide gives black color to silver articles. Similarly, copper. When copper articles are left open in air, it reacts with oxygen, carbon dioxide and water and forms basic copper carbonate, which is green in color. That's why after some time when we see copper vessels, they become green in color. To prevent corrosion, we can apply galvanization, painting, oiling. These things can prevent our metals from corrosion. Rancidity. It is just an oxidation of fatty food. The fats and oils present in our food get oxidized and changes its taste and smell, and we say that the substance had become rancid. It is not edible. To prevent it from rancidity, we should keep the food material containing oils and fats in airtight containers or in refrigerator, or we can use antioxidants like nitrogen. When we buy potato chips from outside, they contain air. That packet is containing air which has nitrogen, and nitrogen is antioxidant which saves our potato chips from getting oxidized or getting rancid. In this way we can prevent rancidity. That's all for today. Thank you and have a good day.